This video is on 7.1, which is going to be an introduction to rational expressions. Now, a rational number is any number that can be written as a fraction. So a rational expression is an expression that has variables on the bottom. For example, these 4 items right here have letters on the bottom of a fraction, so they're rational expressions. To solve them, to evaluate them, you plug in the number and then solve. So if you're given an expression and then you're given a value for the variable, you just plug it in. So here we would do 1 over 2 plus 1. 2 plus 1 is 3, so it would be 1/3. This one, our variable's -4. So we would put, wherever there's a y, we would put a -4. -4 squared is 16. 2 times -4 is -8. And -8 minus -1 is -9. You can leave it just like that, 16 over -9. Then you have an exact answer. You don't have to worry about rounding mistakes. Next one, they tell us z is 1. So we're going to rewrite the expression, but wherever we see a z, we're going to put a 1. 5 times 1 is 5. 1 squared is 1. -2 times 1 is -2. 5 plus 8 is 13. 1 minus 2 is -1. Plus 1 is 0. And you can't have 0 on the bottom of a fraction. Anytime you have 0, we say it's undefined. There's no value for that. So z can't equal 1 in that expression. The last one, and if you feel comfortable, you try it and pause the video and see how you do. So 2 minus -3. And then -3 minus 2. Minus a negative is plus. -3 minus 5 would be -8. 2 plus 3 is 5. So we get 5 over -8. Now, that would help if I wrote things correctly. This is a 2 in the problem. So it'd be -3 minus 2, which is -5. And 5 divided by -5 is -1. So that's why it's always good to double check and look at your work, because little things happen. So I just kind of talked about how any fraction is undefined if 0's on the bottom. So when you're asked, when are these undefined, you just figure out when the bottom would be 0. For this one, I would say x can never equal 0. That would make it undefined. For this one, we would say t minus 3 cannot equal 0. Add 3 to both sides to get the t alone. And we know t can never equal 3. So 3 is when that would be undefined. Do the same thing here. R squared minus 4 cannot equal 0. Add 4 to both sides. So we get r squared equals 4. To undo a squared, you take the square root. And the square root of 4 can be 2 or -2. Because positive times a positive would give us 4. And -2 times -2 would also give us 4. So both of those values would make this function undefined. Now let's do the last one. X squared plus 1 cannot equal 0. Subtract 1 from both sides. Now, when you take a square a number, it's always positive. So the square root of x squared can't be -1. So there's just no value that makes this one undefined. You can plug in anything. That's what that means when you get something that's impossible. All right, now we're going to talk about simplifying. So we talked about greatest common factors in the last one. So to simplify, we find greatest common factors. We find things that they're divisible by and divide. So 8 and 12 are both divisible by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. 2 and 3 don't have any common factors, so that's reduced. It's simplified. 5 divided by 5 is 1. 10 divided by 5 is 2. That's simplified. Now here, let's say there's a couple ways you do it. Maybe you look at 36 and 48 and say, hey, those are both divisible by 6. -36 divided by 6 is -6. 48 divided by 6 is 8. Then you say, oh, those are both even. They're both divisible by 2. We just keep going. Negative 6 divided by 2 is negative 3. 8 divided by 2 is 4. So there you go. We have it in lowest terms. Maybe you looked at it and said, hey, I know those are both divisible by 12. Negative 36 divided by 12 is negative 3. 48 divided by 12 is 4. And you did it in one step. Doesn't matter as long as you keep going until you can't simplify it anymore. This is also true for our rational expressions. If you have a squared or a cubed or any of that, you want to factor first. So this top would be difference of squares, where a is x and b is 1. So that would become x plus 1 times x minus 1. The bottom one's a trinomial, so I'm going to factor a, b, a times c. Factors of 1 that add up to 2 are 1 and 1. Greatest common factor. Multiply up, multiply across, and I'm left with x plus 1 over x plus 1. The reason we factor is because these are multiplication problems. If there's the same factor on the top and the bottom, we can cancel them. For example, we have an x plus 1 on the top and the bottom in a unit with parentheses, so we can cancel those. They're going to cross right out, and what we're left with is our fraction in lowest terms. Let me show you that with this 8 over 12 here. If we did 8 over 12, we could rewrite 8 as 4 times 2, and we can rewrite 12 as 4 times 3. Cancel out the 4s, we're left with 2/3, which is what we got up here. So this, with your rational expressions, we're doing the same thing. We're just using variables and factor pairs, binomials, instead of digits. All right, let's look at a word problem. Suppose a small fish species is introduced into a pond that had not previously held this type of fish, and that population P in thousands is modeled by this equation, where x is greater than 0 represents the time in months. Now, the reason we tell you x is greater than 0 isn't to confuse you, but if you think about it, you can't go back in time, so x wouldn't be negative. Then it says complete the table. We're just going to plug 0 in for x. That's all we're doing. So for this first one here, we would do 3 times 0 plus 1 over 0 plus 4. 3 times 0 is 0. 0 plus 4 is 4. 0 plus 1 is 1. So we get 1/4. And it says 3 decimal places. So if I did 1 divided by 4, I'd get 0.25. You can also type it right into your graphing calculator. I could literally type it in parentheses, but instead of x, type 6. So 3 parentheses 6 plus 1, close parentheses, divided by 6 plus 4 gives me 1.9. Do the same thing, but with 12. So plus 1 divided by 12 plus 4. And I get 2.31, and then the 5 makes that go up to a 3. If you hit second enter, it'll retype your last entry. And then you can just type right over, instead of 12, we can put 36. And this gives us 2.725. Now, if you did this with your calculator and you didn't get the same answer, check your parentheses. You need the top, the whole thing in parentheses. That's why we have the one around the 3 and the 1. And then the one around the 36 represents x. So make sure your parentheses match up. That could be why you're not getting the right answer. Now, if we look at our questions, how many fish were initially introduced into the pond? So we're introducing these. That means on day 0, they're putting fish in the pond. So when time is 0, we had 0.25. Well, we can't put 0.25 fish, so let's go back to our problem. Up here, we're in thousands. So we want to multiply this by 1,000, and that gives us 250 fish initially. Interpret the results. So telling us what we see. If you look at this table, it's going up. Every 6 months, it gets bigger and bigger. So over time, the fish increase. You could say at 6 months there was 1,900 fish. You could say at 12 months there was 2,313 fish. Anything you want that shows we're increasing. And this was covered by the calculator, so I didn't do it. But if you were to enter it, you'd get 2.855. So it's kind of a word problem, little break, how you might see rational functions or expressions in real life. Now we're going to jump back. So up here, we found our common denominator or our common factor and simplified. And we could do that with letters and numbers. So we're going to do the same thing. 8y over 4y squared. Well, we have a couple things. I could say 8 is 4 times 2, and there's a y. I could say we already have the 4 and leave it like that, and y squared is 2y's. And then cancel what's the same, and we're left with 2 over y. That's one way to do this one. Another way would be prime factorization. 8 is 2 times 2 times 2. 4 is 2 times 2, and y times y. Then we cross out what's the same, and we're still left with 2 over y. And then another way you could do it is, if you remember exponent rules, 8 divided by 4 is 2. And if you have 1y on the top and 2 y's on the bottom, you subtract and get -1, which would put that right on the bottom. It's up to you how you do it. Any of those ways will get you to 2y, 2 over y. Now, if we look at the next one, we want to factor the top. So 2x plus 6 has a greatest common factor of x. 2x divided by 2 is 1x, and 6 divided by 2 is 3. On the bottom, they're both divisible by 3. So 3x divided by 3 is x, and 9 divided by 3 is 3. Now we see the x plus 3's cancel. All we're left with is 2/3. You guys try the last two. Pause the video, factor them, reduce them, see how you do. This one's already factored, so we just cross out the ones that are the same, and we're left with z plus 1 over z plus 3. Here we need to factor. The top is difference of squares, so we would get x plus 3, x minus 3. Goodness gracious. Bottom, we tic-tac-toe. A times c. Factors of 6 that add to 7 are 1 and 6. Greatest common factor is 2. 2 times 1 is 2. 1 times 1 is 6. 2 times 3 is 6. So we're left with x plus 3 over 2x plus 1. We cancel out our matching ones, and our final simplified answer is x minus 3 over 2x plus 1. Now I want to take a break for a second and look at fractions. The negative sign can go in lots of places. You can put it in front and just say, like, -1 times a fraction. You can put it with the number on the top, or you can put it with the number on the bottom. All three of those are the same thing. It doesn't matter where the negative goes. You can see it anyway. They're all correct. Using that information, if I look at the top, those are both negative. I can factor out a -1. Negative x divided by -1 is x, and -6 divided by -1 is +6. Now let's look at the bottom. Those are both divisible by 2. 2x divided by 2 is x. 12 divided by 2 is 6. Now we've canceled those just by pulling out the negative, and I'm left with -1/2. When you see the same numbers, 10 minus z and z minus 10, both subtraction with a reverse, but reversed, we can take a negative out of either one. It doesn't matter. So let's take a -1 out of the top. 10 divided by -1 is -10. And negative z divided by -1 would be positive z. And you can write adding in any order. So we could rearrange that as z plus negative 10, which is the same as z minus 10. Bring the bottom straight over. These cancel. We're left with negative 1. Just like pulling it out, you can distribute it. So you can distribute it to the top or the bottom. It doesn't matter. So I'm going to distribute it to the top. Negative 1 times 5. Sorry, my wrist keeps hitting it. Is negative 5. Negative 1 times x is positive x. If I switch the order, I get x minus 5. Bring this one right over. We have the same thing on top and bottom. So if I cancel everything, that reduces to 1. So that is section 7.1, your introduction to rational expressions. Let me know if you have any questions.